On a winter day, King Christopher went to bathe with hot water, but when he turned on the shower, cold water started coming out. The king immediately called Minister Gary to inspect the geyser. "Your Majesty, its wire has burnt." "The geyser was installed by my great-grandfather, and its wire burnt within just 3 generations. Install a wire that lasts for the next 100 generations." "As you command, Your Majesty." The minister went to the shop to buy a wire, but there were many types of wires there, some thin and some thick. "The previous wire burnt due to heating. Should I take the thinner wire or a thicker one? Which one will heat less?" He read a physics book. The heating of a wire depends on its resistance, which in turn depends on its cross-sectional area. A thick wire means less resistance, and a thin wire means more resistance. But the book had 2 formulas for heat loss. In one formula, increasing resistance generates less heat. In the other, more. Which one is correct? I'll test it with an experiment. He took 2 resistors of 1 ohm and 5 ohms and connected them to a battery like this. After some time, when he touched them, the 1 ohm resistor was hotter and the 5 ohm one was cooler. This means this formula is correct. The wire with higher resistance will heat less. I should buy that one. Gary bought a thin wire whose cross-sectional area was 1/4 of the previous wire. For the same length, its resistance would be 4 times higher. He happily took the thin wire and connected it to the geyser. But what's this? After running the geyser for a short time, the wire burnt again. "What happened? We talked about 100 generations, and this didn't even last 1 hour. You will be punished for this." "Your Majesty, please give me one more chance." He got another chance, but where did Minister Gary make the mistake? In the minister's experiment, the larger resistor had less heat loss, where in the geyser, increasing the wire's resistance increased the heat loss. Yes, how did that happen? Because in your experiment, the resistors were connected in parallel, while in the geyser, they are in series. Across both resistors connected to the battery, the voltage was fixed. That's why this formula correctly predicted the heat loss, where increasing resistance reduces the heat loss across it. In the geyser circuit, 2 resistors are connected in series. The first resistor is the geyser's coil, and the second is the resistance of this wire. In this case, the voltage across both resistors will be different, but the current will be the same. Therefore, it would be more appropriate to use this heat loss formula here. This current can be calculated using Ohm's law. The important point to note is that the heater's resistance is much higher than the wire's resistance. So for both thick and thin wires, the current value will be almost the same. Since the thin wire's resistance is 4 times higher, the heat loss in the wire also became 4 times greater, and the wire burnt. But will it last for 100 generations? If it lasts even 1 generation, my job will be done. We can also use the voltage-based heat loss formula in this series circuit by calculating the separate voltage drops across both resistors. Can you tell how we can use the current-based formula in this parallel circuit?